Hello, everyone. I'm Rohan Kumar, Corporate Vice President of Azure Data at Microsoft. I'm so delighted to welcome you to Build and to speak with you today. I have some exciting announcements to share with you today. We believe these advancements will make it easier and more cost-effective for developers to innovate in Azure than ever before. Let's get started. Azure Data Services offer a choice of fully managed relational and NoSQL databases spanning proprietary and open source engines to fit the needs of modern application developers. What sets us apart is our embedded intelligence, scale without limits, and best-in-class security and privacy. And we give developers full flexibility to choose the database engine that fits their needs. Azure Cosmos DB gives you ultra-low latency at scale for cloud-native applications, enabling scenarios like real-time personalization and streaming telemetry. Azure SQL helps you modernize SQL Server applications and multi-tenant SaaS applications. Azure Database for Postgres SQL powers your transactional apps, providing massive scale with hyperscale Citus. Azure Database for MySQL adds enterprise-ready features like high availability, elastic scale, and intelligent performance to your mobile and web applications, and is 100% compatible with community-based offerings. Azure Database for MariaDB provides fully managed community MariaDB for your applications. Azure Cache for Redis is a caching layer that increases your app's throughput and accelerates performance by up to 11 times. It's exciting to see so many customers around the globe innovating with Azure Data Services. Let's take a look at a few examples. Paychex, a leading provider of SaaS-based payroll and HR services, started their journey with Azure by migrating their on-premises environment to Azure SQL Elastic Pools. They've been growing so rapidly that they couldn't build out new data centers fast enough to keep up with their growth. That's why they turned to Azure to gain the scale and flexibility needed to support their growing customer base. Today, their FlexTime app is used by millions of employees every day to clock in and out of work. They're also developing new cloud-native applications using the power of Azure to better serve their customers. Simple Apply is a web application that simplifies the job application process. It is built with a cloud-native architecture using Azure Functions and Azure Cosmos DB. With their employee retention solution, Paychex is going further by using Azure ML and Azure Databricks. This helps their customers better understand employee satisfaction and achieve better retention. It's exciting to see what started off as a simple migration project turned into a fountain of innovation for Paychex. We can't wait to see what they build next. HSBC is one of the largest banks in the world. They are innovating in Azure to build secure, cloud-native, mobile-first applications to rethink the banking experience for their customers. A great example of this is their PayMe application. Built on a microservices cloud-native architecture, the application enables customers to pay for goods and exchange money with one another with their phones. 98% of transactions are completed within 5 milliseconds, providing immediate access to payments. The application is used by thousands of businesses and over 1.5 million customers in Hong Kong alone, about 20% of Hong Kong's population, and runs on Azure Database for MySQL as their core transactions engine. With this solution, HSBC is able to support up to 500 million transactions per day. Now that's rethinking the banking experience. And finally, one of my favorite customers. During this past holiday season, consumers' digital shopping habits continued to accelerate as more people purchased online or from their mobile device from the comforts of their home. Walmart's e-commerce platform generates billions of dollars in annual revenue and grew 79% last year. As they prepared their robust e-commerce platform to handle the demanding load of the holiday season, they needed a cloud-native database that could provide millisecond latency at petabyte scale and handle billions of requests daily with 5 nines availability during their busiest days. Which database did they choose? You guessed it, Azure Cosmos DB. Walmart.com used Cosmos DB for their online transactions using multi-region writes for extreme high availability and sub-10 millisecond latency, providing millions of customers with the items they wanted and the experience they expect. There is no other database in the world like Azure Cosmos DB, offering financially backed SLAs and guaranteed performance at global scale. It's an honor that Walmart turned to Azure Cosmos DB to support its most demanding workload during the busiest time of the year for their business. These are just a few examples of the amazing work and innovation that our customers are driving with Azure Data Services. Now let's switch gears and talk about each area of our data services and the exciting new capabilities and offers we are announcing today. Let's start with Nosql. Nosql has become a popular database for scalable, high-performing, and globally available applications on Azure. Developers love the service-backed SLAs around consistency, availability, latency, and throughput necessary for their mission-critical applications. From retail to healthcare to IoT and gaming, Azure is the best cloud for NoSQL development. As showcased in the Walmart example, Azure Cosmos DB is a fast, ultra-low latency NoSQL database favored by developers for modern application development, which has led to more than 170% growth year-over-year in consumption. With this service, we see applications store petabytes and scale to trillions of transactions per day in a single database to support customers around the globe. With petabytes of data stored across 1.2 million active databases and the ability to scale a single instance to more than 5 petabytes of data, Azure Cosmos DB is the NoSQL destination for modern apps of any scale on Azure. Let's dive into some of the new features available in preview today. To enhance Azure Cosmos DB's performance even further, we are excited to announce the preview of Azure Cosmos DB's integrated cache. With integrated cache, we have seen customers reduce costs by up to 96% while boosting database performance by up to 300% for their read-heavy workloads. Customers like British retailer ASOS are already benefiting from this exciting feature, and we look forward to sharing more about integrated cache in the coming months. We are also excited to announce new enterprise-grade security features like role-based access control and always encrypted. With these new security features, developers can encrypt sensitive customer data before it enters their database management system. And they can enhance their data plane authorization with a fine-grained permission model integrated with Azure Active Directory. Also in public preview today is one of our most requested developer features, the Cosmos DB Linux emulator. Linux developers can now build, test, and learn on Azure Cosmos DB for free on their local Linux or macOS machine. The Linux emulator is a completely free local emulator that does not require an Azure subscription. And to enhance the developer experience on Azure Cosmos DB, and based on the feedback we've heard from the community, we're excited to announce a significant expansion to our free tier offering. Starting today, developers will get 25 gigabytes of storage and up to 1,000 RUs of throughput completely free every month for the lifeline of their account. But that's not all. Today, I'm also excited to announce the general availability of Azure Cosmos DB Serverless. With Serverless, Azure Cosmos DB developers are only charged for the requests and storage consumed by their database operations. Serverless containers serve thousands of requests per second with no minimum charge and no capacity planning required. Developers can use serverless to run applications with bursty traffic and to develop, test, and forecast capacity for their applications before using a provisioned throughput model. Amazing customers like Albertsons and Swiss Re are already using Cosmos DB Serverless for their application workloads. Pairing globally available serverless Azure Cosmos DB with highly elastic serverless Azure functions provides a unique combination that enables mission-critical, event-driven modern applications. With Azure Cosmos DB and Azure Functions, developers can build out cloud-native applications based on a microservices architecture. Not only can we build highly scalable microservices, but developers can leverage our serverless capabilities to achieve a low total cost of ownership. Developers can also take advantage of Cosmos DB's change feed feature to implement novel techniques on how they orchestrate their workloads. The change feed feature effectively blurs the lines between your message queues and databases, resulting in reliable event sourcing. To see many of these exciting new features in Cosmos DB in action, I'd like to invite Deborah Chen on the stage for a demo. Deborah?
Thanks, Rohan. My name is Deborah Chen, and I work on the Azure Cosmos DB team. I'm super excited today to show you how easy it is as a developer to build a completely serverless application using Azure Cosmos DB, serverless functions, and static web apps. For this demo, let's say I'm a developer at Contoso Software Company, where all employees are working from home. To keep us connected, I've built an app in Teams that checks in once every 2 weeks to ask my teammates how they are doing and visualize the company-wide sentiment over time in a dashboard. We do all of our collaboration within Microsoft Teams, so being able to take the survey right from inside this Teams window is pretty awesome. Let's dive in and see how the app works. The first part of our app is an Azure Function HTTP trigger that takes the input from the survey response from Teams and writes the result to Cosmos DB in a container named survey data. I'll hit F5 to run this function locally, and I really want to make sure that when the input comes in, that this item here is being written to the database correctly. To test it, I'm going to use the new Azure Cosmos DB Linux emulator, now in public preview. The Linux emulator, which I've got up and running here, allows me to emulate the Cosmos DB service locally on my MacBook and do all my dev tests without incurring any costs. It also comes with a local version of the Data Explorer, and it works completely offline, so no subscription needed. You can see here I've got my local host URL. We're really excited to release this and get your feedback, as it was our #2 user voice item. Back in VS Code, to make sure my function can connect to the database, all I have to do is configure it so that my Cosmos client instance takes in the endpoint associated with the emulator, as well as the well-known key. And here I've already configured it to use the localhost endpoint, as well as the well-known auth key of the emulator. Putting it all together to test the function, all I have to do is right-click, execute function now, and I'll give it a sample input to simulate someone typing the response in Teams. Back in my Data Explorer here, I'll refresh and see that this item was indeed written to Cosmos DB as expected. Now that we're happy our app works locally, we can now create our Cosmos DB account in the cloud. For this account, we'll use Azure Cosmos DB Serverless, now GA. Serverless is consumption-based, which means you only pay for the request units that you actually consume. It's a great fit for this app because we only need to send this survey every 2 weeks, so there's no charge when the database is idle. In fact, I could write 400,000 server responses a month, all for under $1. Here's a serverless account I've created with some sample data populated, and I've also taken the step to deploy my Azure functions to this functions app in the cloud. Since we're working with sensitive data across the company, we want to make sure that only certain users or applications have access to the data. To do this, we'll use Cosmos DB's Role-Based Access Control, or RBAC, for the data plane, now GA. RBAC allows us to create roles with granular permissions at the database or container level and assign those roles to an identity associated with either a user or an application. So here for my functions app, I've created 2 user-assigned identities, one for each function. We basically want to guarantee that one of my functions will only be able to write data to that survey container, and my other function, which I'll use later in the app, is only allowed to read data from the survey data container. So I've already created these 2 identities here. And I've also created 2 roles where one of the roles is only allowed to read, and one of the roles is only allowed to write. And I've assigned each of these roles respectively to the right Azure function identity up there. Then, in my Azure function, all I have to do in my code is when I create my instance of Cosmos Client, pass in the manage identity credential associated with the identity that I've assigned the role to. Once I have that, all requests will then be authenticated with AAD. Now that the data is secure, we're ready to build a web app to analyze the results. In VS Code, I've got my static web app right here, and all it does is it calls an Azure function. The Azure function runs a query against Cosmos DB to return the average rating per day from the survey, takes the input from the result from the function, and draws a chart to visualize it so we can see it. Now up here, I've already deployed my static web app to production, and I'm using the free tier, which is really awesome. And I've also set it up with a custom domain name here. Go to that URL. And we'll see that indeed it's going to call the Azure function, read the data back, and display it on the page. Now finally, as an optimization, if we expect a high volume of traffic on this dashboard, we can turn on Cosmos DB's dedicated gateway with integrated cache, now in public preview, which will allow us to further improve the performance. When the cache is on, this means that all my read and query operations will be served from the in-memory cache. So if we're running that same query over and over again, I'll get lower latency. And when the query hits the cache, it consumes 0 request units. In conclusion, we've just seen how we can use the latest features in Azure Cosmos DB with a new Linux emulator, serverless, data plane RBAC, and integrated cache combined with functions and static web apps. With all this put together, it's now easier than ever to build your app with Cosmos DB. Thanks for joining me, and I can't wait to see what you build on Azure. Back to you, Rohan.
Thank you, Deborah. Now let's switch gears and talk about our open source databases. Azure's open source database services are hugely popular with developers. In fact, Azure Database for PostgreSQL and Azure Database for MySQL use nearly doubled last year. These services have taken open source community databases to new levels of enterprise capability. One application you may have heard of, Minecraft, generates 17 billion transactions per day on Azure Database for MySQL. Unlike other providers, our approach is to be fully integrated with the open source community and contribute back. Microsoft has made the most contributions to the open source community on GitHub of any cloud vendor. Some of our notable contributions include the PostgreSQL extension for Visual Studio Code and Azure Data Studio PostgreSQL extension. We also built the Citus open source extension, which has had 1.7 million downloads by customers who use it to scale out Postgres into a distributed database. No other cloud vendors invested in the open source community like Azure. And we have some exciting new offers and features to share with you. Microsoft is making it easier and more cost-effective for developers to get started with PostgreSQL and MySQL on Azure. We are introducing a free 12-month offer for a new flexible server preview deployment option, providing the latest community editions of PostgreSQL and MySQL with a simple end-to-end development experience. Another easy way to get started is the new basic tier for PostgreSQL Hyperscale Citus, which provides developers with a cost-effective option to build modern applications that are scale-out ready. Developers can start with just one PostgreSQL node and seamlessly grow to tens of nodes without downtime. Our team at Microsoft is also contributing innovation, code, and leadership into the global PostgreSQL open source project. Our PostgreSQL experts have committed key capabilities to the upcoming PostgreSQL release, including significantly faster crash recovery and increased connection scalability. The latest PostgreSQL and Citus versions are now available on Azure Database for PostgreSQL with Hyperscale Citus. Finally, we are bringing advanced threat protection and security alerting to your open source workloads with the general availability of Azure Defender for PostgreSQL and MySQL. Azure Defender protects your application data and detects unusual access attempts. To see Azure Database for PostgreSQL in action, I'd like to invite Umar to walk us through a demo. Take it away, Umar.
Thank you, Rohan. When building a cloud-native app, if you're looking for a cloud database that's reliable, relational, and open source, Azure Database for PostgreSQL checks all the boxes. For the first part of today's demo, I'll show you two of the new capabilities we've introduced that make it easier than ever to get started with Postgres. Hyperscale Citus is one of the unique deployment options on our Postgres service. It makes your applications future-proof by making scaling easy. It's powered by the open source Citus extension, which transforms Postgres into a distributed database. With the basic tier that's now in preview, you can use Hyperscale Citus on a single node. This smaller footprint means cost savings. In fact, it's now 7x less to get started. But even better, the basic tier gives you the power to build modern apps that are scale-out ready from day one, letting you start small and later grow seamlessly to tens of Postgres nodes. It takes only a few minutes to provision a basic tier database. Once ready, I can check the Azure portal and see that it's running on the latest Postgres version, Postgres 13, and the latest Citus version, Citus 10. We also realize how important it is to do testing on your local dev machine. For that, I'll just run the single docker run command, which we've introduced with Citus 10. Within seconds, I get functional parity with the cloud, with open source Citus and Postgres ready on my laptop. With my databases now ready, I want to switch to the application. What if we built a real-time web app to help fight the COVID-19 pandemic? For its data, we can use the official COVID-19 dataset made publicly available by the UK government under the Open Government License. In the second part of the demo, I want to show you three superpowers that Postgres and Hyperscale Citus gives you for your app. First, let's use the pSQL Postgres client to connect to the basic tier database I created earlier. And let's take a peek into the data model. Here, I have a time series table, which captures metrics across different areas released at different timelines. The table has two partitions. The first partition holds a subset of the data from January to March of 2021, and the second holds another subset of data that's more recent, from April to June. I have about 100 million rows in the time series table, and the table is around 24 gigs in size. Now, as my data grows, can I archive and compress my older data? With Hyperscale Citus, doing that is now as simple as using columnar as the table access method for the first partition. It'll take several minutes to complete this operation. Let's fast forward. And now check the size of the table. 24 gigs fell to 4.2. Just by running a single command, I was able to compress my data by 5x. And depending on the shape of your data, you might see compression ratios of up to 10x. The next superpower is how easy it really is to scale my database. Here, I'll use the portal and add 4 Postgres nodes to my hyperscale Citus deployment, each with 4 vCores and 32 gigs of RAM. Once the nodes are added, and after kicking off a simple command that rebalances the data, you'll see here that the data is being shuffled across the new nodes. What's really cool is that during the entire rebalance operation, your application does not take any downtime, not for your reads and not for your writes. In fact, you can scale your data layer from 2 vCores up to thousands of CPU cores and to terabytes of memory without causing any application downtime. For the third superpower, let's look at performance. Here, I divided my screen into 2. On the left is the original basic tier deployment using 1 node, and on the right is my standard tier deployment with 4 worker nodes. I'll run this query, which gets me the total number of first dose vaccinations conducted across various nations in the UK. On the basic tier, the query finishes in around 3.1 seconds, scanning and filtering 100 million rows. I'll run the same query on the 4-node cluster, and voila, it completes in just around 800 milliseconds. Scaling my database horizontally with hyperscale Citus gave me near linear scalability, 4x the nodes, 4x faster queries. To complete the workload, I'll also run here a short transactional query that updates an area attribute. As I expect from my operational database, it completes in just a matter of milliseconds. Now, what's really great is that the cloud-native application I've been talking about in this demo already exists in the real world. Here's the official UK government website for data and insights on COVID-19. It's a mission-critical app used to fight the pandemic, and it handles 100,000 concurrent users at peak times, and a user table holding 2.5 billion rows of time series data. The query we ran earlier in the demo actually corresponds to this chart on top right-hand side that shows how many citizens have received the first and second dose vaccines. You can click on it to drill down further. The application is very snappy, with hyperscale Citus ensuring 95% of queries are running in under 0.4 seconds. I also want to call out that the data and source code are all open source. Here's the glimpse of the parent GitHub repo of the application. Like many other modern web apps, this app is built with open source software and public data, and runs on Azure Database for Postgres and hyperscale Citus. We're proud to help fight this pandemic and support the hard work and dedication of the NHS teams in the UK. Thanks, Rohan. Back to you.
Thanks, Umar. Turning now to SQL. Azure SQL is our family of SQL Cloud databases, providing flexible options for application migration, modernization, and development. We host over 8 million SQL databases in Azure today. It's the best destination for SQL Server in the cloud, and customers know it. Last year, the number of SQL servers on Azure VMs grew 200%, and the number of Azure SQL managed instances grew 70%. For organizations that manage financial, medical, or other sensitive data, establishing trust around the integrity of data for auditors, regulators, or other business parties is a must. Blockchain has been transformational technology, providing digital trust for decentralized systems. However, how do customers with a centralized database add the trust and transparency that blockchain offers without building a decentralized network? Today, we're happy to announce the preview of Ledger capabilities in Azure SQL Database, enabling tamper evidence through cryptographic verification for your centralized data stores. This is exciting news for enterprise developers because the Ledger feature eliminates the additional cost, complexity, and performance overhead of a decentralized blockchain technology while providing many of the benefits of blockchain, such as tamper evidence in a fully managed and familiar SQL environment. The Ledger capabilities support scenarios like digitizing the audit process for sensitive systems of record often found in industries like financial or medical, introducing verification to multi-party business processes within a trusted, centralized system, and enabling rich analytics on data with existing blockchain networks. And unlike other centralized ledgers that require you to migrate your data to a dedicated Ledger database, SQL Database Ledger is a capability within the SQL database. This means you can easily enable Ledger for your existing SQL data, so you do not have to migrate your data or make any changes to your applications. Ledger is also enterprise-ready with all the performance, scale, and resiliency that comes with being a feature of Azure SQL Database. To see this exciting new feature in Azure SQL DB in action, I'd like to invite Jason Anderson on stage for a demo. Jason?
Thanks, Rohan. Today, I want to show you how customers like RTGS Global are using Azure SQL Database Ledger to get the power of blockchain without the complexity. RTGS Global provides a liquidity network so banks can execute what's called liquidity versus liquidity transfers, or LVL. LVL enables banks to source liquidity in any currency across the globe and in real time without having to pre-fund overseas accounts. This allows banks to source liquidity on demand to complete a cross-border transaction immediately, a process that would normally take hours, if not days, to complete. Azure SQL Database Ledger is used to maintain a tamper-evident ledger of these transactions, enabling RTGS Global to verify and prove to the bank's regulatory bodies that the ledger of transfers has not been tampered with. Let's show you how this works. I'm logged into the RTGS Global application as the Commercial Bank of Seattle. And as you can see, I have currently $3.4 billion available in USD as liquidity available for other banks to source. As I scroll down, you can see the liquidity held in the banks I do business with, the commercial banks of Nagoya, Frankfurt, and the Commercial Bank of Leeds. Let's say the Contoso Car Company, who banks with the Commercial Bank of Seattle, wants to purchase tires from UK Tires, who banks with the Commercial Bank of Leeds. To do this, the Commercial Bank of Seattle needs to secure £1 million from the Commercial Bank of Leeds. So I'm going to initiate this transfer as the Commercial Bank of Seattle. I'll confirm this transfer. Now, as I go back to the dashboard, we're going to see that the transfer was completed. Now, as a bank regulator, I want proof that the liquidity transfers between banks has not been tampered. Azure SQL Database Ledger cryptographically links each transaction in the database to one another, creating a blockchain. The hashes of these transactions are saved as database digests and are the root of trust of the integrity of the database, which are used later to verify the ledger. So now I'm going to switch back to the bank regulator's view of the application. As a regulator, I can see the ledger verification has been executing on an hourly basis automatically, and I can also manually verify the ledger at any time. And we'll see that happening, and it'll be pretty quick. Now, let's take a peek at what's actually happening under the hood. Using Azure Data Studio, you can see that I'm connected to the database that tracks the liquidity transfers for USD, and we can see the transfer I just completed earlier here in the ledger table using the RTGS Global application. Now let's verify the ledger again, this time using T-SQL. First, I'm going to retrieve the latest database digest file from the database by executing the generate database ledger digest stored procedure. The digest is a JSON document which contains the hash of the database, as well as information regarding when the last transaction was committed and the time the digest was created. So let's copy this digest, and now I'm going to run verification using the verified database ledger stored procedure. This recomputes the hashes of the data in your ledger tables in real time and then compares them against the database digests. If the recomputed hashes don't match the value of the hashes stored in the database digest, we know a tampering event has occurred. And as you can see, all looks good. Now, enabling the ledger feature can be done during the creation of a new SQL database or through T-SQL on an existing database. All I have to do is navigate to the Security tab, click on Configure Ledger, and click this checkbox, which ensures that any ledger tables created in the future are ledger enabled by default. Now, I showed you earlier how to generate your database digest and run verification. We have integrated this into the ledger feature to automatically generate digests for you and store them in either Azure Storage Immutable Blobs or Azure Confidential Ledger. Not only does this simplify the process, but ensures your database digests are protected from tampering. Once you've enabled the ledger feature, you can easily run verification by selecting the ledger option in the security settings and clicking on Verify Database. This pre-populates a T-SQL script verification that you can run in Query Editor, Azure Data Studio, or SQL Server Management Studio. In closing, Azure SQL Database Ledger provides customers the ability to get many of the benefits of a blockchain-based system without having to develop new infrastructure, business logic, or migration of data from a legacy system. But Ledger is not just an alternative to blockchain. Any data that is subject to external or internal audits must be trusted that it has not been maliciously tampered. With Azure SQL Database Ledger, you can cryptographically prove that your data is in fact intact. And best of all, Ledger is a feature of Azure SQL Database. This means that you can enable it on your existing databases and get the benefits of tamper evidence right away, with no additional cost and no changes to your applications. Azure SQL Database Ledger will be available in the coming days starting in US Central West, with all regions to follow. Thank you.
Thanks a lot, Jason. Taken together, these announcements further cement Azure as the best cloud for developing intelligent applications that harness the power of data. It is easier and more cost-effective for developers to innovate in Azure than ever before. Get started today. We can't wait to see what you build next.